Hi, my name is Roy, and I'm a team member at AnyLog. Edge computing creates tremendous opportunities in every industry. Specifically, it brings computation and data storage closer to where the data is generated. However, the edge is a very complicated environment. Not only do we need to consume huge streams of data, but we also need to manage distributed and non-uniform data. In addition, data services that are available at the cloud are not available at the edge. AnyLog is designed to make the transition from the cloud to the edge simple, enabling companies to make faster insights and save costs. In this demo, we will show how streams of data are captured at the edge by distributed edge nodes. Without centralizing the data, we will query this distributed data and produce insights on this data, as if the data is already unified and hosted on a single centralized database. This map shows nodes distributed all over the world. Each node is hosting an AnyLog agent that orchestrates the local processing of data, as well as synchronizing the processes with peer nodes, such that all the distributed nodes operate as a single unified machine. The way in which distributed nodes synchronize their operations is outside the scope of this demo, but in short, the synchronization is based on a global and shared metadata layer that is implemented using a blockchain, which is shared among all the participating nodes. Each node on the map is connected to sensors that generate data. From the user's perspective, the only thing that needs to be done is to connect the sensors to the nodes of the network. When the sensor data reaches the nodes, it is hosted on a local database on each node. Using the global metadata I mentioned before, the schemas are shared. This means that if two or more nodes receive similar data, they will apply the same schema to the data. To demonstrate that all the network data is available through a single point, we will connect a Grafana to a node in the network. By connecting to a node in the network, Grafana interacts with a virtual database that represents all the data in the network and can be queried in the exact same way that a centralized database is queried. As you can see, using a single connection to a single node, AnyLog is able to satisfy the Grafana queries from the distributed edge. To show the functionality that AnyLog delivers tangible results, we will use this REST GUI. This is a web application that delivers REST requests to nodes in the network. The connect info, as highlighted above, identifies a node in the network as a target node. Any node can serve as a target node. It is used as the means to connect the network data. Queries are delivered to the target node without the need to know which node hosts the relevant data. This process is done transparently by the query protocol. Our demo queries smart building data. More particularly, we have two refrigerators that generate continuous temperature readings. These refrigerators are in two different locations, and therefore the data is delivered to two Raspberry Pi instances that are next to each refrigerator. This setup represents data distributed on many edge nodes. The first query pulls rating data from two edge nodes. Looking at the query is not told where the data exists. It only asks for the generated data of the last 10 minutes. If we scroll down to the end of the query, the summary section shows that the data came back from two edge nodes and the query time was roughly 1 to 2 seconds. Let's query the source data to find the reading where temperature is above 30 degrees now. Again, if we scroll down to the bottom, we see that this query was processed by two nodes. And let's look at the average temperature in each freezer. Again, we can see the average temperature of both refrigerators. In a similar way, here is a query to the average temperature in all freezers. Again, we can see the results here. We can extend this approach to thousands of freezers, and the process works as if the distributed data is centralized. The data is queried from my browser, pulling unified results from distributed edge nodes. And I'll use Grafana to pull two freezer data to show that applications interact with the data using standard APIs. If you have a similar use case, you can download a trial version and deploy the network on your setup. In addition, this setup makes cloud integration simple. As the data is unified at the edge layer, we can transfer the data to a Kafka instance that will feed a cloud or a data process. In this example, we will deliver the readings with temperature above 30 degrees to Kafka instance by changing the format to JSON. As you can see, the query returned the result in JSON format. So far, I demonstrated telemetry data. The same approach is applicable to unstructured data. Let's assume cameras are deployed at the retail locations. In addition, each camera feeds an AI process that counts the number of people at each location. The query to the AI insight is in a time range that ranks the number of people at each location. As we can see here, we have the number of people, and we also have the confidence level above that says your confidence on how many people are in this video. Then we query the specific images that we would like to see. So in this example, let's query an image with 2 people and an image with 5 people. And we will run this query. And as you can see, the results returned a video stream of people of 2 people and of 5 people. Note that in this example, both the AI insight and the videos are stored at the edge, but are queryable from a single point as if the data is centralized. The last thing that I will demo is managing all the resources from a single point. Here is a web page similar to what a user operating in a cloud would get, but here the resources are distributed at the edge. Very similar to the data approach, all the edge resources are managed from a single point. As you can see here, we have all the different data that we're pulling into our system at the edge. The last thing to say is that this demo was done without a single line of code. Deploy the software and you can immediately run queries on your edge data and manage your edge resources as if the edge is a single machine. Thank you very much for listening to this demo.